Well, welcome everybody to the University of Lethbridge. It's really nice to have a big beef meeting here on campus at the University of Lethbridge. There are people that like beef here at the university, and we want more of them. So it's good to have everybody here. So, thanks also to Karen for inviting me for this speak. To give this talk. I've been working on food waste for a few years now, and it's nice to be able to give a talk about it. Feeding food waste to cattle, it's not a new idea. It's even in the Bible they talk about gleaning, where the first crack after you harvest the field, the very poor people can go in and try to glean and take what they can of the grain. And then after that, the beasts of the field are supposed to go in. So that would be the cattle go in and take kind of what's left over. So always cattle have been using the food that humans couldn't. For whatever reason, it was spoiled or it was too fibrous, couldn't be digested. So this, let's see if I can get a little laser pointery thing. So this farmer here, he's from the early 19th century, and it looks kind of like he's feeding waste, well, it's some kind of slightly processed bread products to his great square beast there. Different fashions in cattle in the early 1800s. Legs, doesn't seem like legs were all that important. I'm old enough I can remember back in the 1970s when all the Italian draft breeds were really popular. They were all legs, no nothing else. Outrun a horse, but I digress here. So let's move on with food waste. So our food and manufacturing distribution systems, they've changed a lot from previous centuries. So instead of food all being locally produced and fruits and vegetables only eaten when they're in season, we're shipping food all over the world and back again, it seems like in some cases. And industrial food processors, they're making a lot of byproducts, things that can't be used in the human food chain, and they become waste if they're not otherwise used. And that includes things like best before dates at grocery stores or mistakes in ordering, or it means that a lot of good-looking food is ending up in landfills. And current estimates are that about 48% of all food in Canada is wasted annually, and that's this is the Canadian government doing this wonderful estimation, sir. So $58 million wasted, which is a fair bit. Not all of this is food that we can capture for feeding to livestock. So about half of it here is that's after it's already been delivered to consumers, and we can't really consider that half of the food waste because the CFIA has rules about that very strong. Anybody from the CFIA in here, so I can kind of speak freely, like identify yourself, please? No, that's good. I can say what I want. So all we can really focus on is this half of the food waste that's before it gets delivered to consumers. So this little chunk here, 13% occurs on farm, and we're not talking about anything to do with, it's not like cattle dying. This is just things we could possibly feed to cattle. So this is like crops not being harvested or being discarded due to their not making quality standards, or just not having enough storage for them, or not enough employees to do the harvest. So the next 20% of food waste, that occurs at processing, and that's due to malfunctions or poor quality inputs or trimming and culling, or problems with equipment, or just not knowing what to do with some of the byproducts that are produced. And so 12% of food waste here is down in retail sales. That's damaged goods, poor inventory. And then about 5% is through transportation. And so that's just loss of refrigeration, spilled loads, different things like that. So not all of this, even this half of food waste here, not all of it is it's things that we can capture as feed. So like it's unlikely we're going to be able to get the 5% from transportation, and there's some of the on-farm losses that definitely we can't get. So even if we've got only like half of the half, that's still billions of dollars of food waste that's readily available. So the question is, what do we do with this stuff? So because I'm basically older than dirt, I remember back to the mid-1980s when I was starting my master's degree at University of Alberta, and most of the students who were finishing, it seemed, as I was starting, they were all working on canola meal. So how much to feed to chickens, how much to feed to pigs, and feeding canola meal to cattle was a lot easier. Cattle could tolerate all of the fiber. They didn't pay much attention to the remaining anti-nutritional factors like the glucosinolates. But canola was a brand new crop, and when it was first it was the first role for canola, like the main role for canola is for vegetable oil. The canola meal is just a byproduct that they really didn't know what to do with when it was first introduced. So the little bit of research that would have occurred to evaluate canola for beef diets, that would have happened before I got to the U of A. Maybe Erasmus would know about that. But yes, sorry. Yeah, well, no, you look better than I do, Erasmus. So sometime in the early 1970s, that little bit of research would have come, but it took what was a novel byproduct just from making cooking oil into a standard feed ingredient. So so byproducts don't have to stay as waste. So the next byproduct, which really hit the big time, is distillers grains, and it comes in many forms for many different grains. And the growth of ethanol as a fuel market suddenly increased the availability of distillers grains, and there were a lot of research studies that were conducted in the 1990s on how best to feed distillers grains. Until now, it's a standard feedstuff too. But once the kinks are kind of worked out of the price of byproduct feeds, the price goes up once the kinks are worked out, which is a little bit unfortunate, but knowledge is also power. So next byproduct, grain screenings are not news, I'm sure, to any of you, and it's another commonly used byproduct feed, but one that's at high risk for contamination with ergot. And I want to just fill you in on a little bit of our very recent findings about cereal ergot. And ergot contaminated grain, it's a very cheap feed source, which if it can't be fed to livestock, it's wasted. People, they set it on fire, they can't sell it. But free feed to is a little problematic if it harms your cattle. So these little purplish guys, I seem to have lost my laser pointer, but oh well. The ergot bodies are the purplish things in the picture. They're packed with a lot of different mycotoxins that they negatively affect feed intake, growth rate, and they're also vasoconstrictors. They reduce the blood supply to various parts of the body. So they can be lethal also if they're in high enough quantities. And I'm part of a group of researchers that's led by Dr. Gabriel Ribeiro at the University of Saskatchewan, and this is with BCRC funding, working to try to figure out how much ergot can be fed before problems start to appear, and looking at things like mycotoxin binders. But one of the things we have figured out is if you have ergot-contaminated feed, it's best to feed it in the wintertime. It seems like there's less problems with feeding ergot in backgrounding diets in cooler weather. And we don't know, is it the higher forage in the backgrounding diets, or is it the lower temperatures that's making the difference? Not really sure. Maybe it's both. But once temperatures in the day start getting over 20 degrees Celsius, this is a picture of from the U of S, and start seeing cattle with a lot more signs of heat stress. And these cattle were being fed 3 parts per million ergot alkaloids, which is a lot of ergot alkaloids. But they were being fed the same amount in the winter time in backgrounding, and no signs of heat stress. So the thermoneutral zone in cattle is such that they can handle our typical winter temperatures better than they can any sort of heat, and that's without feeding any ergot. But adding ergot to the diet makes them even less able to handle warmer temperatures. And so then that's due to the vasoconstriction of the blood vessels, meaning they can't dissipate the heat as well. So this is some other very recent findings, and this is a PhD student, Darby Meyer, that's doing this work with Gabriel. If you're worried about feeding ergot and are having a wreck, you can feed it intermittently. And one week feeding ergot, they're feeding 2 parts per million ergot alkaloids right now, and then 5 weeks not feeding ergot, then there's no difference in performance. The cattle can have compensatory gain and make up for that 1 week of ergot. So that's it for brief ergot update. I'll move on to other food wasty issues. So I'm part of a food waste study that's Dr. Stephanie Terry, Ag Canada here in town, is leading, also BCRC funding. And we wanted to find if there were some other sort of easy to transport, high nutrient quality food waste byproducts that had potential for use in cattle feed. And Vicky Garcia, Dr. Vicky Garcia is part of the, she did this survey. Vicky, you can wave from the audience, yes. And so she surveyed thousands of Canadian food processors to try to identify these underutilized food wastes that might be useful as cattle feed. Unfortunately, thousands of food processors did not respond to our survey. No one likes surveys. But we had about 100 different responses in total to the question. This was just asking them, what do they currently do with their different byproducts? And we can see, I'll get back my laser pointer here. We can see that feeding to livestock is by far the number one choice of what they want to do. Not very little to biodigestion, or nobody wants to send things to the landfill if they can avoid it. So one thing that came out of our survey is that we had a lot of hemp processors that answered our survey, and that's likely because hemp byproducts are not allowed as livestock feed in Canada. And hemp byproducts, there's a lot of different ones. So hemp screenings, hemp hulls, downgraded various hemp products, hemp seed protein, some other underutilized products that we thought were maybe more useful as feed, included things like coffee grounds, organic herb residues, and also mixed or unsold chocolate, but those would be in smaller supplies. So we thought these are going to be probably easier to work with, easier to transport, things that are a liquid slurry, and that's more difficult to work with and more prone to spoilage. And these would be easy to work with if there wasn't this other little hurdle towards using novel feeds, and this is where my CFIA dissing comes in. Okay, so CFIA has a list of approved feeds for all livestock species, but if what you want to feed your cattle is not on the approved list, this doesn't make the CFIA happy, and you could be issued with a fine or your cattle not allowed to enter the human food chain. The CFIA, they want to assure the safety of the feed, and that's admirable, but even though they are the same species, hemp is not the same as marijuana. Hemp contains less than 0.3% THCs, which are the psychoactive ingredients. And this is another little comment here. Marijuana and hemp, they used to be more similar back in the old days, but Agriculture Canada, this is just my opinion here. No one else, this is not the opinion of the University of Lethbridge. It'll get, so back in the 1990s, Agriculture Canada, they fired a bunch of plant breeders. And it's possible that some of them went to the dark side because there were sudden huge jumps in THC content of Canadian marijuana started in the 1990s. So within 5 years of the plant breeders losing their jobs. So maybe not a coincidence. But anyway, back to food waste. So hemp seed meals, they're high in protein, and other protein products like hemp hulls would be high in fiber. They would be valuable feed, but based on some recent research, hemp byproducts should not be fed to dairy cattle. Like it seems like the THC and its derivatives accumulate in milk, and maybe at high enough concentrations, excuse me, to cause toxicity, especially amongst young children. So I guess we could try to market an adults-only happy milk, a new value-added product, but it's likely a bit too complicated for the CFIA to consider. So, okay, I can hear you thinking, I don't really care about dairy cattle. This is not a dairy cattle audience. How do hemp byproducts affect beef? And there's better news there. Only trace amounts of THC and derivatives were detected in the fat and none in the lean part of meat. And concentrations of THC in the fat were so low as to not be judged a food safety concern. And so the authors of this paper, excuse me, my son gave me a cold that I just haven't got through it yet. They were feeding 20% hemp seed cake on a dry matter basis to cattle over a 111-day feeding period. So hemp byproducts for beef cattle actually look good. But how exactly you get a feed added to the CFIA list, though, is not completely clear. Oh dear, excuse me. As a little extra bonus, the cattle that were fed the hemp byproducts in this, oh, thank you. They showed markers for reduced stress. So there's not a sign that they also had the munchies and increased their feed intake, but definitely working with exceptionally chill cattle would they be easy to work with, I think, if they were being fed hemp. Okay. No, we're not. So next on the potential feeds of feeding coffee grounds, there's many tons of coffee grounds that are heading to landfills on a daily basis all over Canada. And coffee grounds were identified in the survey. There's some older studies showing that coffee grounds can make up to 20% of the diet of beef cattle with no reduction in performance. And coffee grounds are surprisingly high in protein. They run about 12%, and they also have substantial fat and fiber. And this particular paper here was looking at the fermentation in diets containing coffee grounds, and provided that they didn't exceed 20% of the diet, all was well. So the high fat concentration in coffee grounds, it's a consideration. They'd need to be fed fairly quickly after they were received. You don't want the fat to go rancid, but looks to me like coffee grounds should be readily mixable in with the rest of the diet without need for extra processing. And we just need to get them on the CFIA list of allowable feeds. Would all that residual caffeine lead to nervous cattle? Not sure about that, but maybe we need to combine coffee grounds with hemp byproducts. In Japan, Starbucks in Japan is recycling their coffee grounds, so they're splitting between feed and fertilizer streams, and they've been doing that since 2010. But the Japanese and the Koreans are way ahead of Canada when it comes to using food waste as feed, and I'll talk a bit more about that in a bit. So, coffee grounds, they have to be fed quickly because of high fats, fairly high moisture, but no additional processing would be required. To just auger them into your feed truck, little bit of a mixing, and voila. The same can't be said of waste fruits and vegetables. Oftentimes they require some additional processing, maybe a lot of chopping before they are incorporated into silage or fed quickly to avoid spoilage. So this is another part of the food waste study that Stephanie is leading, and this is evaluating some food waste for utility as feed. So next few slides are we're looking at incorporating cull carrots into silage, and photos are courtesy of Janine Hansen, who's the PhD student who's doing a lot of the work. So. Why carrots, you might ask? Well, approximately 50% of carrots are judged to be too ugly for human food. So they're crooked or they're lacking the aesthetically pleasing carrot shape. So that leaves a lot of carrots that need to find another use. And in this study, we made two types of carrot silage. The one on the left this one here is mixed with oat hulls, which is another useful byproduct. And this one was mixed with chopped straw. And sorry if it's offensive looking at a picture of sheep, but logistics are easier for these food waste evaluations to try them first on sheep. You have to make a lot more silage to feed to cattle. And Ag Canada has recently purchased a small-scale silage processor that chops all your ingredients, mixes them up, then packs them into neat little research-sized bags that weigh approximately 30 to 40 kilos. So perfect size for feeding to sheep. I don't have all of the results from this study yet, but it seems like the chopped straw plus carrots was the winning combination when it came to the silage making. So, okay, when we're feeding food waste, the first concern is that it's not going to harm the cattle. And we did a study of food waste from retail grocers, looking at that and making silage out of that. And the reason that some of the fruits and vegetables were being discarded is because they were spoiling, which included growing some mold. And whenever mold is present, the immediate concern is mycotoxins. And in the grocery food waste study, we didn't put anything into our silage mixture if it was too far gone. And if the fruit or vegetable was mostly a fungal mat, we discarded it. But that's a little bit difficult to do at any scale, which is maybe why some of the retail grocery wastes are best suited to smaller scale farms. So this is some results from our, should have made that type bigger. In our grocery store food waste silage, we were blending drier bread products with a variety of fruits and vegetables, targeting 38% dry matter in the silage. And when the silage was first made, like at day 0, we're just sampling it we're packing it into the silos, there were significant yeasts and molds present, but and that was just based on basic microbiological plate counts. But after 60 days of fermentation, molds, yeast, they weren't detectable. So converting the food waste to silage is helpful for dealing with spoilage organisms. And I just put in a little plug, all of our food waste for that study came from the superstore here in town. But Save On Foods also has a food waste recycling program. So there's various food recycling programs ongoing. So we did a commercial mycotoxin panel on our retail food waste silage, and the only mycotoxin which was detectable in the silage at the day 0 when it was first made is this mycophenolic acid. It's an immune suppressor and not something you want in feed. But after 60 days of fermentation, it was reduced to undetectable undetectable levels. So even at day 0, though, the concentration of mycophenolic acid was approximately 20 times lower than is typical from regular grass silage. So it wasn't enough to really be a concern. So from food waste, it's likely not a food safety concern for feeding your cattle based on our mycotoxin results, but it's a good idea to keep your eyes on that, depending on what you're feeding. And this is just our research paper from that food waste study. Get over here. So in the retail grocer study, we were working with Loop Resources, and they were started by a Canadian farmer that assumed that their local jurisdiction was a bit behind the times when it came to recycling food waste, but actually, nope, nobody was doing a good job of it. So starting in 2017, they've been matching farmers to retail grocers, and they've kept more than 148 million kilos of waste food out of landfills. So more than 4,000 farmers. And the farmers are contracted. They go pick up the food waste from the grocery stores at a specific number of times per week, and then they take the grocery waste home to their livestock. You never know exactly what you're going to get or how much you're going to get, which is why we wanted to see how easy it would be to turn this grocery store food waste into silage. And it contained all kinds of stuff, like including vegetables. I didn't even know what they were. I'd never, what is this? With the silage, then you can stockpile the food waste instead of having to bring it and feed it almost as soon as you get it home. So, okay, depending on the food waste source, plastic may be something that needs to be dealt with before the food waste becomes useful as a feed. Big chunks of plastic, you're going to have hardware disease, little fine pieces of plastic, and then you've got microplastics, which are not good for the cattle or the environment. On a small scale, like our retail grocery study, you can just manually remove the plastic, and approximately 2.5% of our grocery food waste that we received was plastic. Another 7.5% was cardboard. But on a larger scale, you need to have choppers equipped with blowers that are helpful to remove the plastic from food waste. But my thoughts are that too much of our food is wrapped up in plastic, and there's no need for every cucumber to be in its own individual plastic container. So, okay, we're worrying about mycotoxins because they can harm the cattle, but there's some other microbes that can cause problems either to cattle or that can be transmissible back to the crops. And one of these is powdery scab on potatoes, and with the potato processing plants in southern Alberta, there are potato peels and cull potatoes that make good feed for cattle. So there's approximately 2 semi-loads of potato peels per day per plant being fed to cattle right now, which is a fair volume. But some of the potatoes can be affected with this powdery scab disease. It doesn't cause harm to cattle, but it's a fungus-like protozoan. It's actually a type of slime mold, and it's a very difficult to kill organism. It can survive passage through the digestive tract of cattle, and that wouldn't be a problem, except the potato industry is encouraging the use of manure, at least occasionally, as a fertilizer to improve soil health. So, but quite possibly the fermentation that occurs during silage production, that might be enough to kill off the powdery scab. We're not sure. Maybe it takes just a day of aerobic heating of the waste potatoes before it's put into silage. Maybe that's required. Not totally sure what it takes to kill off powdery scab, but it's definitely something that we'll chalk that up in the need to know more information about this section. So this is Roquette, Canada. It's a pea fractionating plant in Portage la Prairie, and it's supposedly the world's largest pea fractionating plant. And they're selling actually a fairly small percentage of the overall pea as this amazing plant-based protein, beloved of vegans. But before Roquette put a shovel into the ground to start constructing this plant, they needed to find markets for the many different byproducts among the local area livestock producers. And so contracts had to be in place for this material. Some of it's easier to feed, things like pea screenings. There's also pea cream, which is a frothy liquid that's mostly going to local pig producers. But I always find it a bit ironic that without livestock to use the byproducts, some food processors wouldn't be no longer financially viable, or food would have to be a lot more expensive. And this is funny when the plant is making loud claims about the healthiness of their plant-based products, and they're still relying on livestock for financial viability. So that livestock are needed for the success of many food processors is a point that the general public just really doesn't understand. So, okay, it's not completely easy to use some types of food waste. I'm going to take some extra adaptations and feed testing, but I guess if it was easy, everybody would be doing it. It does have some advantages though, and one is availability. Even in drought conditions, when a lot of different feed becomes in short supply, it's a lot of this food waste is going to be available. Another can be cost. Often you just need to pay for transport, but then there can be increased costs from different handling required or acceptable testing. But the third thing is consumer acceptance. There's the anti-animal agriculture PETAs of the world. They've done a good job of encouraging veganism by trying to make cattle look like environmental villains. But consumer responses to feeding food that can't be used by humans, they're overwhelmingly positive when the general public is told about this. So the average person doesn't have any understanding of what cattle eat, and that livestock have always done this recycling. So converting organic materials that people couldn't or wouldn't use into high quality protein. So I'm wildly guessing that the use of food waste as a feed is going to increase in the future. We have an increasing population, we lose arable land to urban sprawl. So more food waste probably in the future coming. So in Canada, we've got advantages. We've got considerable food production and processing that gives us a lot of different byproducts with potential use as feeds. But on the minus side, there's substantial food processing that's centralized into large urban areas, things like the Greater Toronto area, long ways from farms, making transportation more expensive. Japan and South Korea, they're leading the world in recycling food waste for livestock, and they have centralized food waste processing facilities, but they're also much more compact countries compared to Canada. But in Japan and South Korea, their regulatory agencies are promoting the recycling of food waste for feed, which is very different from the CFIA. That they're just kind of getting around to the idea. There was a lot more information on food waste in the 2024 updated feed regulations that the CFIA put out, but there's still a long ways to go, especially on having clear directions on how to get a novel feed included. So this figure here is showing how food waste is currently streamed in Japan, and they actually have a food waste recycling law that they're taking post-consumer food waste as well, so from people's houses and from restaurants that we're not able to do in Canada. So we have a ways to go before we have the same kind of support for using food waste as feed as there is in Japan. So that's probably it. Probably good that my talk was well separated from lunch. Happy to answer any questions.
Does anybody have any questions?
Rob's closer.
I was curious about that powdery scab. Do you think if you composted the manure, that might be an approach?
Yes, that like there are different levels of easiness, I guess. And yeah, it might take composting the manure. That composting kills just about everything and degrades galvanized metal. So I think maybe it would do the same for powdery scab. Not sure. It's another question.
Hey, Kim, enjoyed your presentation. Just a question about practically, how would you see making the vegetable silage? Would you be pulling out of one end of the pit and chopping and filling at the other end? Because obviously the vegetables come on a regular basis.
Yeah,
throughout
no,
the feed.
you need like a continuous flow through silage pit where you just kind of keep putting out, packing on one end and feeding out the other end. And some places have that. It really depends on what you're trying to ensile, but we just been evaluating things after 60 days, and that seems to do a good job for killing off some of the bad bugs, we'll call it.
I apologize if I butcher pronunciation of names, but Foucan said, not sure how much it will cost to manually remove the plastic from those waste. Labor in Canada is too expensive comparing with us in China. Should I consider this part of cost into my production cost?
So this person is from China. They have an advantage by hiring cheaper labor, but here we need to mechanize it. So we need to have some different choppers and blowers, and people are like, there are people that are feeding like waste or stale bread products that comes in a nice plastic bag, and so they run it through a chopper blower system that captures the plastic. So we did it manually because we had no budget, and I had students that were quite happy to eat the food waste. Like, it was difficult keeping them from eating it because it looked some of it was really good, like these cookies and Black Forest cakes and things that looked delicious, but so neither here nor there.
Dr. Fred?
Kim, do you have recommendations for producers trying to use ergot contaminated grains? What are the preferred assays or the preferred labs to use in order to determine exactly, because it's complicated chemistry.
It is. It's horrible chemistry, Fred. I guess Prairie Diagnostic in Saskatoon, we've worked with them. They do a decent job. None of them are good. Sorry. It's kind of, we were, for our ergot studies, we're shipping them to Austria, to the DSM people, that because they developed some of the assays, but that's a research basis. But I'd say probably here in Alberta, Prairie Diagnostic is probably as good as you're going to get. But you have to take the ergot assays with a grain of salt a bit, because it seems like a lot of things can influence how much ergot is detected in your grain. Nothing, and it's not. So it's fluctuating too much. It's not reliable. But so yeah, sorry to be Debbie Downer here.
I was just going to ask, how fast does that list of acceptable things on the CFIA list evolve, or has it been etched in stone for a pretty long time?
That's something that I'd like to know. I don't really have a good concept of how easy it is to get something else on there. I know people have been talking about hemp byproducts for quite a while. So actually Vicky, she won't identify herself this time, but she's doing an undercover study to try to, on the down low, see what it would take to get a new feed registered by the CFIA. So we should know in a little bit. Better idea.
We'll let you grab a microphone. It's for the people online so that they can hear.
Kim, I wondered about, especially when you're dealing with ergot and there's such a variability between quantities coming in from the seedling plants and all that kind of stuff, and of course the varieties can vary in terms of ergot type. What about partnering that up, not eliminating it, but partnering it up with something like a liver and kidney panel? We did that looking at mycotoxins in feed, because typically most mycotoxins affect the function of the liver and kidney, and if you partner with that, and it's fairly cheap and fast to do. Your thoughts?
It doesn't, like, the problem is if you not feeding ergot continuously and you do this test, if the cattle haven't had ergot for, it's less than 24 hours, you can't find any sign that they've ever had it in anything. So I know Gabriel was trying to do some work to try to like, that's part of his I have a dream sort of to try to see if there's something that can be detected in the liver, because right now we don't really understand why, if there's nothing that we can really find, the ergot can have these long-lasting impacts. Because there were cattle that they never recovered from heat stress even when the ergot was withdrawn from the diets, and there was nothing in their blood or nothing in their liver that would say that there was anything wrong. But so there's something else going on that we don't know yet. But that, that's a good suggestion, Brenda, but I don't think we're quite there yet.
Dr. Joyce asks, how do you balance these kinds of rations? I've seen milk fever outbreaks in feedlot cattle fed bakery waste, as the nutrient content of each load varies all the time.
It's not easy, Joyce. You're going to have to be taking a bunch of different samples, and you need to kind of have an idea of how the waste, maybe it's going to fluctuate on a yearly basis. Like, there's different products. It really depends what you're working with. So yeah, you can run into problems. There's going to be extra costs required for more feed analysis and things like that, so that you can balance a diet and not get into trouble.